I'm Scott Francis, CTO of BP3, and my partner in crime here, Ivan Kornienko, is our Director of User Experience. And we're here to help you sleep at night with static code analysis for at least for IBM BPM models, and eventually BPM in general. BP3 is a BPM specialist provider of services. We have offices in Austin, London, Kiev, Portugal, and now Sydney, Australia. But we're not just a services provider because we're very much interested in user experience. And as a result of that, we've written software. Brazos is probably what we're best known for. It's got the #1 user interface framework on IBM BPM. We're producing a version that will work against other BPM tooling. And if you're interested in seeing that, talk to my colleague Brian Johnston after the presentations today. He'd be happy to show you on his phone. Customer experience, though, is about more than just user experience. So we could actually solve these hard problems, not just the UX problems, like quality control issues. We could actually write software for that.
Okay. Now, before there's a solution for the business to experience, it takes shape within the process models, UIs, integrations, and other code being written by BPM developers. Neches is our solution for automated code and implementation analysis. So let's say we take a task with a project to build a new BPM application. The solution must meet a specific set of business and functional requirements to be fit for use. The budget is tight, thus we need to keep costs down. First, finding the right platform is a challenge since BPM has been around for a while, and as we're seeing this week, there are many excellent options. Different vendors offer a variety of features and approaches to solve similar problems. More than one correct answer is actually out there. Next, the experts. Ideally, the whole team is made out of consultants that have built dozens similar solutions in the past. Realistically, many team members are likely to be new to a given technology and unaware of all the best practices and anti-patterns that exist for that technology. When the solution is built, it's easy to assess the outcome when it's a clear failure. Missing the basic requirements will stop it from getting through UAT. Of course, with iterative development and frequent business contact, this is unlikely failure mode. A more likely failure mode is the completed solution meets the basic requirements and seemingly does everything the business needs. The issue may just be surface over time. Poor performance, awkward UI design, difficulty adding new features, or maintaining the existing ones. So how does Neches help here? By programmatically examining the BPM solution code against the set of best practices and anti-patterns curated by BP3 consultants that have been building similar applications for over a decade. This allows us to find specific code bits or configurations that adversely impact the solution performance, make it difficult to use, and a challenge to test due to inconsistent UIs, or a struggle to maintain. Simply put, we're examining the solution implementation complexity. Refactoring a completed production-ready solution is expensive, time-consuming. There's lots of code, a variety of patterns, and many excuses, or perfectly valid reasons, why things are done a certain way and not according to best practices. Worse yet, it's nearly impossible to end up with an ideal solution at this point, since the foundation is likely flawed due to all the poor practices building up over time. A complete rebuild is really the best course of action at this point. The good thing is that all this bad code isn't introduced all at once. It builds up over time, gradually growing into something unfixable. When poor assumptions or untested designs are not evaluated and corrected as they are introduced, the seeds of poor user experience are planted. This is why the right time for Neches analysis is at the end of each iteration. Issues identified by Neches early on in the development lifecycle are easy to fix, and developers can investigate and resolve the Neches findings from a given iteration before the end of the following one. To accommodate this use case, Neches is available in the cloud, accessible to anyone, and provides instant feedback. The feedback, or as we call it, findings, is also structured specifically for BPM solutions and is transferable from vendor to vendor. Each finding breaks down into one of 4 categories. From the bottom up, process and business models, user interfaces, exposed and consumed integrations, and documentation. These categories are defined to cover all parts of a BPM solution. Moreover, each finding is assigned severity. High severity means the underlying issue needs to be fixed immediately. Low severity finding won't adversely impact your solution, but may grow into something unmanageable over time. Overall, solution implementation complexity is summarized by the Neches score. The more complex the solution, the higher the Neches score. This score is used to anonymously compare solutions to to determine relative quality of the implementations. So getting into the demo here. So Neches is run in the cloud, so it's a SaaS tool. Anyone can sign up for an account. Of course, I'm running this locally, but it is available in the cloud. Users upload and export of their application directly into this interface here. So if I click Browse, I could upload and export. Now, with IBM BPM specifically, a single export actually has the user interfaces, the integrations, the model, the implementation. Everything is basically part of a single file. So in that case, that's currently the use case that we cover. So we upload that one file, and Neches analyzes it for best practices accordingly. So I have a single export loaded here. It's this fraud investigation solution. So this is a process application. In total, the process application has 800 artifacts, so it's a relatively large application. What we're looking at now is the composition of the application. So the application comes as a snapshot. And it also uses a variety of toolkits. IBM has this great dependency management component where each individual toolkit is really a complete process application in and of itself. In this case, each snapshot is assigned a different score. So as you see, 827, that's that relative Neches score, relative complexity of the fraud investigation process app, but we also have the scores of each individual toolkit that particular process application is using. Also on the right, we see a artifact composition footprint. So this is the bit that actually helps us compare one solution to another and allow people to understand the relative complexity of their application as compared to others. So this one outlines, basically identifies the integration services, the number of human services, number of various artifacts and components that actually make up this solution. With this, I could drill down through the dependencies. All the different toolkits that make up this overall application are actually loaded, so I can drill down into various components. In this particular case, we get to a toolkit that actually has quite a bit of snapshots loaded into it. What we could do with this, once we do have multiple snapshots, is actually look at a timeline. So this is the part that talked about in the presentation about being able to run Neches as part of every single iteration, provide feedback to developers, and fix it before the next one. So this is a visualization over time. This is one bit that we're still working on, so it's not perfect. But the idea here is over time to be able to see the Neches score as compared to the number of artifacts, as compared to findings that are introduced, fixed, and resolved in each one of these. Okay, so now getting to the actual findings, this is really the bulk of the application here. Findings are categorized into a number of categories, as I mentioned here. So the bottom one is the model category. So this is the actual complexity of the process models. This is the complexity of the business objects. In this case, this is something where rules pertaining to the complexity of the bpmN diagram would apply as well. And actually, we have at this point, we're able to pass through standard bpmN diagrams and also get insight about complexity of those diagrams. So that's our model. Then we move on to coaches, which is basically the UI side of it. So IBM offers this construct for creating custom widgets, and we can test the complexity of those widgets as well as the complexity of the interfaces that are created with them. And before lunch was actually really interesting. The Bonitasoft presentation from Miguel was interesting because it's a similar situation where you're now letting developers create their own widgets, and what's inevitably going to happen is may take a little overboard and create things that are a little too complicated and things that have a rich feature set but have limitations to them as well in terms of performance, in terms of maintainability. So very similarly, these types of rule sets can be applied to those constructs as well. You just need a firm construct for defining user interface components. Then the scripting, so this is the server-side script, so complexity of the JavaScript that's being written by the developers, complexity of the XML mappings, all the other bits that basically generating lots of code that's difficult for somebody at a later point to pick up and figure out what has actually been done. And finally, all the way at the top, smallest wedge, but still very important, is the actual documentation. So this is the documentation of each individual component. So I want to make sure there is documentation. So when new developers pick up on a given application, they're able to figure out what has occurred or what purpose of each of these pieces is. Also, there is the severity. And as mentioned in the presentation, basically high things need to be fixed immediately. They have a high impact on either the maintainability of the solution, testability of the solution, or basically on the complexity of the solution, or low things that are, if this is an early iteration in the development of this application, these are things that, if not attended to, will grow into something unmanageable over time. Each rule, and here we have the rules, so I'm going to click into one of these rules. So this is a JavaScript blocked length rule. So this one is a simple rule, basically looks for the length of certain server scripts that might be contained anywhere in the application. So this application is quite large, so there's quite a few of these, and the ones that are actually identified are only the ones that are problematic. But each rule associated with it has an explanation of why something is wrong or why something is a poor practice and could impact one of those things that talked about. It also gives recommendations about how to actually fix that particular issue. We also have the ability to see how each individual artifact, and in this case it's actually an item within an artifact, so you might have several of these within one artifact, but you can see how each one of these is able to actually impact the overall complexity, the overall score of your solution. So based on the number of lines, a certain number of points is added to the overall score, and that number of points, of course, factors into the overall Neches score here. That is the rule. The other way to look at this is from an artifact perspective. So from an artifact perspective, so that was based on the rule, so now if we look at it from the other angle, this is basically each individual artifact that makes up the application. So in the artifact view, we actually have a representation, so we have the different developers that worked on each one of these artifacts, of course, when each one of these was updated. If we click into each one of these, we see the actual set of rules that were broken, that were identified within that particular artifact. So when it comes time to, for each individual developer to investigate these, they basically go to the artifacts that apply to them and are able to attend to all the different rules that have triggered within a given artifact. And then of course,
and if you think about how people develop, right, they tend to go, I want to either fix the artifact completely and address all the rules in it, or I want to address all of a particular type of validation error or finding across the whole model, right? So there's kind of different ways to slice and dice the work.
Right, yeah, absolutely. Okay, so the other component is over time, as you look at a very large application, and in this one we're looking at an application that had, I think, over 100 individual activities. So when we look at larger applications, there's bound to be certain code components within those applications that may have been used at one point, but they're no longer used. So for example, in this case, we see some test services. What we can do with each one of those is we can basically hide them in each case so they don't impact the overall score. So we get a more detailed, more zeroed in representation of the actual complexity of the solution, excluding some of these test services that are part of the snapshot but haven't just been deleted for one reason or another. And the same thing can occur from a rule perspective. If there's a certain rule where basically you've accepted that this rule is being broken, but for one reason or another you actually disagree with the rule, disagree with specifics of that rule, you're also able to exclude the rules themselves. So that way you can have a more accurate representation of your actual complexity there. The other important bit to note is in terms of bringing on new team members, and we talked about the overhead of perhaps having folks involved that have not worked with the technology before. What we've seen success with this tool as well is from a training perspective. So this is a context-specific way for new team members to understand the limitations of a given platform. So it was just a note there. The last piece is in terms of collaborating and sharing these components. So there is the ability to actually share a given space. So everything that I've uploaded, I could share it with others. So each person on the team obviously doesn't have to upload their own component. That doesn't have to do their own exclusions. So you can add multiple people to the a given space and give them either the right of uploading new snapshots or purchasing reports for new snapshots. So that gives you the ability to collaborate in a single space, and everybody sees the exclusions, everybody sees the same report. Basically everyone's on the same page there. And that is it.